Okay, at this point, you should be an old hand at the order of operations. We've seen the order of operations with whole numbers and integers, and now you're seeing it for the third time with fractions. So the good news is the order of operations does not change, okay? So recall the order of operations is the set of rules used to determine the sequence in which operations are performed in mathematical expressions. This ensures that everyone gets the same result when solving expressions, okay? And as a reminder, the steps are perform all operations within grouping symbols. A lot of times we think of that as just parentheses, but remember, it's more than just parentheses. You can also have brackets. You could have curly braces. You could use a square root. You could also have an absolute value. Okay. So if you have any kind of operation happening inside any of those, so operations being addition, subtraction, multiplication, division, you would want to take care of what's inside first. And if you have multiple, you work from the inside out. Okay. Next, you want to evaluate expressions with exponents. Sometimes we can throw square roots down here too. Then you multiply or divide in order from left to right. And then finally, you add or subtract in order from left to right. So a lot of students will use PEMDAS, which is very similar to please excuse my dear Aunt Sally. Okay, that just helps you remember the order. Just remember multiplication and division happen at the same time from left to right. Addition and subtraction happen at the same time from left to right. So let's practice. For example 2, it says use the order of operations to simplify each expression. Is it? Yeah, it's just those two. So let's get to it. Okay, so for part A, we have 1/2 plus 1/5 times 1/3. So when I'm dealing with the order of operations, especially with fractions, because there's going to be some side work, I'll usually keep like part of the right-hand side of the problem free for side work. Okay, so I have addition and I have multiplication. We have to do the multiplication first. So let's look at off to the side. 1/5 times 1/3. Now, this is where you can really test yourself. I have students all the time say, I know what to do, I just don't know when to do it. Unfortunately, with fractions, if you don't know when to do it, you don't know what you're doing, okay? So you've really got to make sure that not only do you know how to do the steps when you're guided, you know how to do the steps when you're not necessarily guided. So you need to understand the steps for multiplication and division compared to addition and subtraction. So with multiplication and division, I do not need an LCD. I just have to multiply across and I can simplify as I go, okay? So in this case, my numerators are just 1. There's not really anything to simplify. So I just want to multiply across. So I get 1 times 1 for the numerator and 5 times 3 for the denominator. So the denominator is 15. So I'm going to come over to the left and I'm going to rewrite the exact same problem, but instead of 1/5 times 1/3, I'm going to replace it with 1/15. So I have 1/2 plus 1/15. Now all I'm left with is addition. And we know, hopefully we know, that with addition, you do need an LCD. So we've got to do a little bit of work here to get an LCD, okay? So let's work on finding the LCD. How would I? Let's do the LCD table. I think the LCD table might be a little bit quicker here. So with the LCD table, that's where you do prime factorizations. You want a row for each denominator and a row for the LCD. So let me erase that. Okay. And then you want to fill in the prime factorization for one of your denominators. So let's do 15. So if you were going to write a prime factorization for 15, you don't really have to do any work. 15 is just 3 times 5. Okay? And then 2, you don't have to do a prime factorization. 2 is prime, so that's just it, 2. So I know I have a 3's column. I know I have a 5's column. I can't put a 2 in either of those columns, so I need to start a new column for the 2. And remember, the number of columns that you have in your table tells you the number of factors you have in your LCD. So I've got a 3 factor, a 5 factor, and a 2 factor. So let's see, 5 times 2 is 10, 10 times 3 is 30. So that tells me that my LCD is 30, okay? And I think that would be a little bit quicker than listing out multiples, because if we were listing out multiples, we would have to list out basically 15 multiples to get to 30 for the 2, okay? So hopefully you're getting better at finding LCDs, but just know both methods, all right? So now what we want to do is we want to find equivalent forms of both of these fractions using 30 as the denominator. So let's start with, whoops, 1/2. So I want to rewrite 1/2 as something out of 30. So you have to ask yourself, what do I multiply 2 by to get the LCD of 30? That would be 15. So if I multiply the bottom by 15, I have to also multiply the top by 15, which makes this 15 thirtieths. We want to do the exact same thing, but for 1/15. So I want to rewrite 1/15 as an equivalent form with 30 as the denominator. So again, what would I multiply 15 by to get the LCD of 30? That would be 2. So I want to multiply top and bottom by 2. So 1 times 2 is 2. So then we're just going to rewrite this entire problem using these equivalent forms we just found. So 1/2 is equivalent to 15 over 30. And 1/15 is equivalent to 2 over 30. So now we have equivalent forms of the fractions, but these have a common denominator, which allows us to move forward. So when you finally have your common denominator, you just add or subtract your numerators. So we're going to get 15 plus 2 over 30, which is 17 thirtieths. 17 is prime. It is not a factor of 30, so we're done. Okay, so the order of operations luckily has not changed, but just know that when you're dealing with fractions, there's going to be a good bit more side work. So they're a little bit lengthier. Okay, now for part B, we have 3/4 squared divided by, in parentheses, 3/4 minus 12. So we do see two sets of parentheses here, but only one set is considered grouping symbols. The first set around the 3/4, that's not really grouping symbols. That's just making sure you understand that exponent of 2 goes to the whole fraction 3/4. The second set of parentheses, those are grouping symbols. So we're going to deal with that first. So off to the side, we have 3/4 minus 1/12. Okay, so we do need to find an LCD. Okay, so if we were going to list out factors, we would start with either the 4 or the 12, it doesn't matter, but I would start with a 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So we can see that 4 divides into 12 evenly, which tells me that 12 just kind of by default is the LCD. So the LCD here is 12. So what we want to do now is find equivalent forms of both of these fractions. So looking at 3/4, we need to rewrite it using 12 as the denominator. So what would you multiply 4 by to get 12? Well, that would be 3. So I have to multiply the top and the bottom by 3, which makes this 9/12. And luckily for us, the second fraction already has the LCD as the denominator, so we don't have to do any extra work there. So we have 3/4, which is really 9/12 minus 1/12, which gives me 8/12. And for now, I'm going to leave this alone because I want to see what happens with my 3/4 squared, okay? So for now, we have 3/4 squared divided by 8/12, and we can reduce that in a minute, okay? We just kind of want to see what happens with our denominator with 3/4. If you're itching to simplify this, you can go ahead and divide top and bottom by 4, which makes this 2/3, which is fine, okay? Now, next up, we want to deal with the exponent, okay? So 3/4 squared, you have to remember, if you have a fraction with an exponent, the exponent, as long as your fraction is in parentheses, the exponent applies to both the numerator and the denominator. So that would make this 3 squared over 4 squared. 3 squared is just 3 times 3, which is 9. And 4 squared is 4 times 4, which is 16. So what we have now is 9/16 divided by 8/12, or if you want to, you can use the 2/3. Now, you have to remember with division, we convert to multiplication. So the first fraction stays exactly the same, and then we multiply by the reciprocal of the second fraction. So we multiply by 12/8. Okay, now we want to look for common factors top to bottom. I know that 9 can be written as 3 times 3 if you need. 16 can be written as 4 times 4. 12 can be written as 3 times 4, and 8 can be written as 4 times 2. So we're looking to see if there's anything in the top that cancels anything in the bottom or that divides out with anything in the bottom. And we have 1, 4. This 4 here, and we'll say that 4 there, they divide out. So 4 divided by 4 is 1. 4 divided by 4 is 1. Let's see how this simplifies. So 3 times 3 is 9. Times 3 again is 27. Times 1 is still just 27. And then 4 times 4 is 16. And 16 times 2 is 32. So we get 27/32. 32. So when it comes to that 8/12 that we had over here, you could have simplified right then and just dealt with the 2/3. So then you would have had 9/16 divided by 2/3, or you could simplify here. It doesn't really matter as long as you get it fully simplified. Okay, so that is the order of operations with fractions. We're not trying to give you the hardest problems ever. We want to make sure you understand the order of operations. That's super duper important. And just understand generally how it works with fractions. Okay.